Hello and welcome to part 5 of Dev Maths and Stats Refresher Course, Lecture 4. Now we're going to look at how to find the determinant for a square matrix. And any square matrix has got a determinant, and it's crucial to calculate the inverse, and it also helps you understand other properties of the matrix, as we will see. Maple can do it for you, but for this course you should be able to do it for 2 by 2 and also for 3 by 3, at least to get the determinant. The notation is like this: matrix M, it's written as determinant of M like this with the 2 straight lines. So first let's do 2 by 2, and then we'll do 2 by and then 3 by 3. So if this is a matrix, I'm just clearing the definitions here, but a matrix ABCD, the determinant for this is just given by AD minus CB. In other words, it's the product of the leading diagonal minus the product of the other diagonal. So this times this minus this times this. You do the calculation, you get 41, and the 41 is the determinant of F, and that's why here we have to divide by 41. So that's how you get determinants. The other part of finding the inverse is you have to know what's this 7, 4, 5, 3. How do we find that? So what comes to that next? The process then is, once you have the determinants, to find the inverse, you swap those two numbers on the leading diagonal. So they swap with each other, they change places. The other two numbers stay in the same place, but they move from positive to negative or negative to positive. In other words, you multiply by -1. And then you divide by the determinant, and that gives you the inverse. So let us just go through the steps for this for F, which is 3, 4, minus 5, 7. So the original matrix F is 3, 4, minus 5, 7. So to get the inverse, the first thing we need is determinant of F. That's the determinant. And that's equal to the product of the leading diagonal, so 3 times 7, subtract the product of this diagonal, which is minus 5 times 4. So that's product of the leading diagonal. This is product of the other diagonal, but we have to subtract them. And this is where many errors occur in this kind of work, is that we make a mistake with the negatives and we go wrong. So you have to be a little bit careful. So here I'm going to have 21. Here's 20, but it's plus 20. And that's why, sure enough, we get to the 41, which is the number we have to divide by. The next thing we need is to rearrange these numbers. And the way it's rearranged is, let's just write this straight down. So F minus 1 is going to be the inverse. And what you do is you exchange places here. So 7 comes to here and 3 goes to there. Okay? After you've done that, then you multiply each of these by -1. In other words, it changes sign. So this is positive 4, so it becomes -4. But it does not move, it stays there. This is -5, and it becomes positive 5. And finally, to get the inverse, you just divide by 41. When I'm working by hand, normally I leave it like this. It's simpler to work with, really. But if you want, you can write this form. You can write it the same way as Maple did up here. You can write like that, it's the same thing. Okay, so that's 2 by 2. Now, so moving to 3 by 3, that depends on, you apply the 2 by 2 several times, 3 times really. So I'll show that. One more thing you need is this template like this, which is just 1, minus 1, 1, minus 1, 1, minus 1. And this can extend for 4 by 4, 5 by 5. What you do is, to calculate the determinants, you choose any row or any column. You just choose one of them. For each entry in that row or column, you calculate a cofactor, which I'll show you how to do that in a moment. It explains it here. And the steps are laid out here, but I'm going to let you read that and just go through and do matrix A by hand in 2 different ways, so you can see how it's done. If you find this is very easy, then please just whiz forward and have a bit of practice yourself. But just to show you that it is possible, I'm going to go through and do it by hand on the whiteboard. Which means we're going to need matrix A, of course. So here we are on the whiteboard. I've just pasted in matrix A to save some time. The other thing we need is this. I find this a more convenient way of remembering the pattern which I mentioned that we need, which is we need this pattern of plus, minus, plus, minus, plus, minus. So that's what I've put in here, plus, minus, plus, minus, plus, minus. It's easy to remember. So then, to find the determinant of A, what you do is you choose any one row or column. So first I'll do the obvious choice and show you how you can do it with the first row here. So 3, 1, 8. So in that case what you do is you take the first row of signs, so plus, minus, plus. So it's plus here. I can leave a lot of space because it's usually minus and then plus like this. I'm going to show you two different methods. Then you take these numbers 3, 1 and 8 from the top row because I'm using this row here. Now this is the part which some people find that it gets a bit tricky. What we're going to do is for this number here, this one, you ignore this. Now you have what's left is a small 2 by 2 matrix. We need the determinants of that matrix. As I said, the 3 by 3 determinant is based on many 2 by 2 determinants, in fact 3. So if you find the determinant of this matrix here is this leading diagonal, subtract this. So if I write it out in full, it's going to be minus 2 times 1 minus 2 times 0. So this times this minus this times this. Okay. Then we move on to here. It's the 1, which means we ignore this and ignore this. So now we have a different 5, 0, minus 1, 1 matrix that's remaining. That's going to be, these are all times by the way, 5 times 1 minus 1 times 0. Okay. 5 times 1 minus 1 times 0. Okay. Then move on to the last one, which is the 8. So let's remove this. So we have 5 times minus 2. You see it's incredibly easy, and perhaps I will do it myself in a moment, so make a mistake. Look at this. So many negatives. 5 times minus 2, subtract minus 1 times minus 2. There's 3 negatives. So easy to make a mistake. So I think now I'm going to forget the colour coding and just try and simplify this. So I've got 3. This becomes, well, this is just 0, so times that times, so 3 times negative 2 from here, minus, and then we have, this is nothing, so minus 5 from here, 5 times 1 to make it a bit more symmetrical, plus from over here we have 8 times, so this is a bit more interesting because we've got here a minus 10, and here this is positive 2 but negative here, so it's minus 2, so 10, negative 10, minus another 2 is negative 12, which looks like it's going to end up at around negative 6, negative 5, negative 196, right? 8 times table, minus 96, so this looks like it's going to come out in the region of 96 plus minus another 11 is minus 107. So that's the determinant according to this method. Determinant of A is negative 107. If we go back to where we had the inverse of matrix A up here, yeah, that's that's the negative 107 we're divided by here. So in fact, it's a negative determinant. That's all you need to know. However, you can make life more easy for yourself if you make a different choice. For example, if I were doing this myself, I just want to know the determinants. I would not choose this row. I would probably choose either this row or this column. So if you're getting bored, please fast forward, but I'm going to show you the steps for finding the same thing, except for this time I'm going to use the last column. Get some ink back so here. Now I'll try and remember to do the same colour coding. You can compare the steps. In a moment I'll point you towards an excellent pair of videos that show how to do this as well. So first thing we're going to get then is this pattern here. Now I'm coming down this line here, so it's going to be plus minus plus again. From this line here corresponds with that. So I can have an 8. Oh no, I've got wrong with the colour coding. So it's an 8 from here, then a 0, and then a 1. Now hopefully, now you can see why I've chosen this column, I think. Because when I come to put these brackets in, so now I'm going to have this one here, which we already know is this thing here. So, but I suppose we wouldn't know, would we? So 5 times minus 2 minus 1 times minus 2. So that's going to give us the same thing here, the minus 96 as before. But the nice thing is, when I go to the next one, oops, because there is a 0 here, there's no need for me to do this one. I can just skip this because it will be 0. And this is why I choose the column, because I choose the column which has got 0. I could also choose the row which has 0, but I want to show you how you use a column. But if you choose this, it's also a good choice. So if you're really doing this, if you can see a column which has 1 or 2 zeros in it, that's the one you want to choose, or a row. So to finish this off, then we come to here. Of course, this all depends on, we should get the same result as negative 107, otherwise the whole thing will be a bit of a disaster. So let's see. We come to here. This looks more interesting. We have 3 times minus 2 minus 5 times 1. Now I hope this is going to come to negative 107, but we'll see. So we know this is negative 96. We already did that up here. So this must be negative 11, although we're in problems. Otherwise we've got problems. So this is minus 6, minus 5 is indeed negative 11, which gives us minus 107. It's the same as this. So you can choose any row, any column, you get the same answer, but my advice is to look for zeros and choose the row or column which has some zeros in it to make it easier. Before I go back to this, let me just see if I can point out some really good resources here. This one has it all laid out very nicely, and you can get as much practice as you want. You press a new problem when it's virtually ready. Okay, and just generates a new problem. So you can try and work it out yourself, and then it gives you a solution laid out in the same way as I've been doing it. Downside of this is because it's automated, they're always using the top row. So sometimes they're not using the most efficient method, but you can apply this to other rows and columns. So that's one good resource. There's also a video there explaining it. This one's also a nice illustration because this shows you how the 3 by 3 determinant relies on the smaller determinants. So it's first, those are the determinants of the smaller matrices, and then it leads you through doing each calculation until you get to a final result. And again, when you press a new problem, you get a new problem to work through. So plenty of practice there. And then here is just 2 really nice videos. This second video is using the method I have just showed you, again using the top row. but the person has main advantages. They have much nicer handwriting than I do, and also they have some nice bits of sticky paper. This, however, is a method that it does not show you the concept of how the determinant depends on the smaller determinant. So conceptually, it's not so good, but it's quicker. So if you just want to learn it to do speed of calculation, then this is quicker. But it's not so helpful for understanding the concepts. But you can have a look at both of those. Okay, go back to the notes and finish this off then. So now we have the way of getting the determinant here, the 107 or the 41. You could apply the same one to find out what this mystery C was really. So that's for a 3 by 3. The examples are there showing how to get the 107. So all that remains in this section is just for you to try and get some practice. I won't write all of these out, but let me expand these, and you should be able to do these yourself. So that's F, we know, comes out as that. That's C. So C comes out as negative 80. So negative 80 somehow is cancelling down here. Let's give you those answers. Determinant of I3, there are some important concepts in here. Determinant of I3 is 1. So I3 is that identity matrix. So determinant of identity matrix is just 1. The determinant of the transpose of A, well, there's A. Determinant of the transpose is 107. Okay, so it's the same. So transposing it makes no difference. What about the determinant of A inverse? That's 1 over negative 107. So it's the arithmetic inverse of the determinant. Yeah. So the determinant of A inverse is 1 over the determinant of A. So compare this to this. If I multiply the determinant of A times the determinant of C, sorry, first I calculate, actually maybe I should show this more clearly in the notes. There's A, there's C, and there's, must be capital, and there's A times C. And then what's the determinant of A times C? So that's the reminder of matrix A, matrix C. If I multiply this times this, this is matrix A times C, and then I find the determinant of this. So the determinant of this answer is 8,560. What happens if I separately calculate the determinant of A and the determinant of C, which I know gives me negative 107 and negative 80. If I multiply those two determinants separately, then what I get is the same thing. So a useful fact here is that the determinant of A times the determinant of C is the same as the determinant of A times C, which can be very useful. And you'll see this kind of thing cropping up. In fact, a lot of the kind of vector and matrix algebra we've seen, you'll see in sort of statistical textbooks and articles and so on, explaining the theory of why things work and deriving different results. Okay, that's enough time on inverses, identities and determinants. So in the final part of this lecture, we're going to move on to one application, which is simultaneous equations. But for now, thanks for watching.